Ever watched the weather forecast and thought, how is it rain in my backyard but a blizzard 40 miles away? Or seen buffalo get buried while another city on the same lake barely gets a coating? Here's the secret. Winter storms don't all work the same way. Some are giant organized weather machines, some are tiny and fast but intense, and some are basically a fire hose of moisture aimed at a mountain range. Today on Untamed Skies, we're breaking down 4 winter storm types so you can instantly recognize what's coming. Classic mid-latitude cyclones, including nor'easters, Alberta Clippers, lake effect snow, and atmospheric rivers. If you've ever wondered what any of these terms mean, stick around. Once you see the patterns, you'll never look at a snow forecast the same way again. Let's dig in. If you're into storms, wild weather science, and learning how to separate fact from fiction the next time you see a weather forecast, hit subscribe. We do this kind of breakdown all winter long. Alright, storm number 1 is the classic one. The big swirling monster. This is the classic mid-latitude cyclone, the workhorse storm of North American winter weather. See that big L? That's the low pressure center, and notice the 2 different front symbols. The blue triangles are the cold front, indicating the front edge of the cold air bulldozing in. The red semicircles are the warm front, indicating the front edge of the warm, moist air gliding up and over the colder air. Now, look at the precipitation shading. Green is mostly rain, usually in the warmer air, often south and east of the low. White is snow and mixed precipitation, most common to the north and northwest of the storm's track, where cold air dominates. Now, see that white to green transition? That's the battleground, where the atmosphere argues about whether precipitation stays frozen or flips to rain. That's where you can get sleet, freezing rain, heavy wet snow, and the kind of travel conditions that turn a normal commute into why did I even try? If you haven't already, check out this other video I made about the one special ingredient that controls winter precipitation type. Link is in the comments below. Here's the key idea. The low's track is everything. If the low passes south of you, you're more likely to be in the cold sector. Hello, snow. If it passes right over you, that's often where the messy zone lives, mixed precipitation near the boundary. And if it passes north of you, warm air can surge in. More rain, more slush, more heartbreak for all you snow lovers. Most classic mid-latitude cyclones follow a few storm highways. They often form or strengthen in the central US and then ride the jet stream northeast toward the Great Lakes or into New England. That's why these storms can have huge impacts across multiple states in one shot. Heavy snow in the cold sector, rain and flooding in the warm sector, ice in the transition zone, and often strong winds wrapping around the low. It's a full weather buffet, just the kind you didn't ask for. Now, let's focus on the one storm track that rolls up the east coast of the United States. This is where a nor'easter enters the chat. A mid-latitude cyclone that develops or intensifies near the coast like this can tap into ocean moisture and enhanced temperature contrast between the land and the sea, enhancing the storm's intensity and heavy precipitation. And the name? It's simple and very old school. Along the mid-Atlantic and New England coastline, when the storm is positioned offshore, the winds blasting into the coastline often come from the northeast, or nor'east wind, especially from the perspective of sailors and coastal communities, hence nor'easter. That northeast wind can mean heavy coastal precipitation, snow inland, rain closer to the coast depending on the temperature, strong wind gusts, coastal flooding and beach erosion, and sometimes those blockbuster snow totals when the cold air stays locked in. And just like we said earlier, track is everything. A tiny shift in where that low sets up can be the difference between a cold, powdery snowstorm and 34 degrees with cold rain. Storm number 2 is the one that doesn't mess around. Meet the Alberta Clipper. These storms usually originate near, yep, you guessed it, Alberta, Canada, on the lee side of the Canadian Rockies, and then they race southeast and east across the northern US. Unlike their slower nor'easter counterparts, an Alberta Clipper zips along and the precipitation shield is much narrower than the big classic cyclone. That's because Clippers are often moisture starved. They're like a storm running on cold air and jet stream speed, not on deep Gulf moisture. So what do? They offer up a quick hit of light to moderate snow, often just a few inches over a few hours. Gusty winds that can create blowing snow and sudden visibility drops, and a very classic Clipper calling card, a fresh shot of cold air behind it. The kind that makes you question your life choices. A Clipper is the storm that shows up, dusts the region, steals your heart, and leaves before you can even find your snow brush. But here's the twist. Clippers have a favorite after party, and it can be way more intense than the Clipper itself. This is lake effect snow, and what we're calling winter storm type number 3. And it's basically the atmosphere doing something unfair. Here's the recipe. First, you need a cold wind below 32 degrees Fahrenheit blowing over a lake. Then the lake water needs to be relatively warm, and then the lake adds heat and moisture into that cold air, and the air starts to rise. The rising air cools, clouds build, and downwind, you get snow. sometimes lots of it. Those upward arrows are the lake feeding the atmosphere heat and moisture, turning it into a cloud factory, which is why lake effect snow is often more intense in the early winter months when the water is still relatively warm before the lake has a chance to freeze over. And because this is more like snow showers on steroids than a big organized storm, lake effect snow often comes in bands. Narrow corridors where it can snow hard in one town while another town nearby sees almost nothing. Now, let's focus on the Great Lakes. When an Alberta Clipper or even a classic mid-latitude cyclone moves through, the winds behind it often turn west or northwest because the storm rotates counterclockwise in the northern hemisphere. More on that and the magic of the Coriolis force in a future video. And that's the magic angle. If the wind direction lines up across the axis of the lake, it can generate a ton of snow downwind of Lake Superior, Lake Michigan, Lake Huron, Lake Erie, and Lake Ontario. This is why locals talk about snow belts. The lakes aren't just scenery, they're active weather engines. And once the mid-latitude cyclone pulls out, lake effect can keep dumping snow for hours, sometimes days, as long as the cold wind keeps streaming over open water. Ultimately, the wind direction is the steering wheel. A small shift can move the band and completely change who gets hammered. That's why lake effect forecasts can be so precise and so stressful. Storm type number 4 looks harmless on the map, until it hits a mountain range. This is an atmospheric river, a long, narrow corridor of concentrated water vapor transport. Think of it like a river of water vapor in the sky, funneling Pacific moisture straight into the west coast. Notice the green plume. That's where the rain is focused. But then, watch the white areas pop in, showing snow in the mountains. That's the mountain effect, orographic lift. When moist air is forced up over the Cascades or the Sierra Nevada, it cools rapidly and the moisture dumps out, sometimes as torrential rain at low elevations and feet of heavy mountain snow at higher elevations. This is why atmospheric rivers are a huge deal. They can build the snowpack that feeds rivers all summer. They can also bring flooding, landslides, and major avalanche conditions. And the rain versus snow line can rise or fall depending on temperatures, changing impacts dramatically. In other words, atmospheric rivers can be a blessing, a disaster, or both, depending on elevation and timing. Check out my other video about atmospheric rivers, linked in the comments below. So here's a recap of our 4 major types of winter storms. Number 1, classic mid-latitude cyclones. Big organized systems with fronts, snow north and west, rain south and east, and a messy mixed precip zone in between. And nor'easters are a coastal version of this type of storm, famous for heavy snow, wind, and coastal impacts. Number 2, Alberta Clippers. Fast, compact, and usually moisture-starved, bringing quick snow and a shot of cold air. Number 3, lake effect snow. The Great Lakes, turning cold wind into snow bands. Hyper-local, sometimes extreme. And number 4, atmospheric rivers, a Pacific moisture fire hose, capable of producing heavy rain and snow across the US West Coast. Now I want to know, which of these storms is the main character where you live? Nor'easters, clippers, lake effect, atmospheric rivers? Drop it in the comments. I read them. And if you want more weather breakdowns like this, hit like, subscribe, and I'll see you in the next one, right here on Untamed Skies.